Hello student, in this video I am going to discuss about Poisson and exponential distribution. In most statistical applications, Poisson and exponential distribution plays a much less important role than normal and binomial distribution. But however, in many applied management science models, the Poisson and exponential distributions are key distributions. So, in statistical scenario or application, people mostly apply or try to adopt the normal and binomial distribution. But in applied management science, different type of problem for different type of problem, Poisson and exponential distributions are key distributions. For example, much of the study of probabilistic inventory models, queuing models, and reliability models relies heavily on these two distributions. So here you can see three major example of management science models. One is probabilistic inventory models. Second one is queuing models, and third one is reliability models. Those are heavily used in case of management sciences, applied management sciences. And in those scenarios, Poisson and exponential distributions are used. So the Poisson distribution is a discrete distribution like binomial distribution. It usually applies to the number of events occurring within a specified period of time or space. Here that distribution applies to the number of events occurring within a specified period of time or space. Its possible values are all of non-negative integers. So the values used in this distribution should be all non-negative integers like 0, 1, 2 and so on. And there is no upper limit of those values. Second, even though there is an infinite number of possible values, this causes no real problems because probabilities of all sufficiently large values are essentially zero. Though the convention is that you can use 0, 1, 2 non-negative values and there is no limit, it does not create any problem having that infinite number of possible values, because the probability or possibility of having larger value, sufficiently larger value, are always essentially remain at zero mark, or you can say the probability occurring a very bigger number is zero in case of Poisson distribution. The Poisson distribution is characterized by a single parameter, usually labeled as lambda, which must be positive. Here you can see one more characteristics. Lambda is labeled as, in case of Poisson distribution, as a parameter which must be positive. It is both the mean and the variance of the Poisson distribution. So lambda is single parameter and it both mean and variance of the Poisson distribution, and it is often called a rat. It might be variable per hour, for example. So lambda is the parameter which signifies both mean and variance of the distribution, and also it can be called or termed as a rat. That rat might be like arrivals per hour, or something like that. If all Poisson distributions have the same basic shape as in the figure below, that is, first increase then decrease. Here you can see Poisson distribution where lambda equal to 5. Lambda equal to 5 means that is the 5 in the 5 position, it is most higher value of probability. So though they are taking non-negative integer, having larger value than 5 in this case is almost 0. And also here you can see the increasing sense of or trend of the distribution is steep at first, and when it decreases gradually in a exponential decaying fashion. Typical examples of Poisson distributions are like, suppose a bank manager is studying the arrival pattern to the bank. The events are customer arrivals, obviously. The number of arrivals in an hour is Poisson distributed, and lambda represents the expected number of arrivals per hour. So here, suppose you want to model a system which involved with the business, like suppose a bank manager want to model how many customers arrive per hour in the bank, then the arrival pattern or number of arrivals is the event here. The event is like customer arrivals. The number of arrival in an hour is Poisson distributed, and the rate, or you can say arrival per hour, can be termed as lambda. Or second problem where or example is a retailer is interested in the number of customers who order a particular product in a week. So a retailer suppose want to take some interest on or a number of customers who ordered a particular product in a week. Then the events are customers order for the product, or might be the number of customers ordered in a week is Poisson's distributed, and lambda is the expected number of orders per week. That is also a rate in case of that expectation number of orders. So in this type of problem or in this type of example, you can apply Poisson, because here lambda signifies the rate and it also signifies the mean and the variance. So that is why it is very useful in this kind of example where you are trying to find out the rate of occurring an event. So in Excel you can use the Poisson using Poisson function. So here one or two examples are present in the slide. Try to go through this so that you can understand by applying the Poisson on a specific data set. Okay, and how this thing acts on the data, how you can manipulate the things, and what will happen if you manipulate any data or the values. And the last distribution we are going to talk about, that is exponential distribution. And this is most common probability distribution used to model the times between customer arrivals. So here that exponential time distribution, it tries to find out the difference of time between two customer arrival, often called as inter-arrival times, is the exponential distribution. So to understand this inter-arrival timing pattern, we can go for exponential distribution. In general, the continuous random variable x has an exponential distribution with parameter lambda. if the density function of x has the form like this. So the condition is, the first condition is that a continuous random variable x should be continuous random variable, and it might follow that x might follow exponential distribution with a parameter lambda which should be greater than 0 if the density function of x has the form like this: lambda e to the power minus lambda x for x greater than 0. The mean and the standard deviation of this distribution are both equal to the reciprocal of parameter lambda. Lambda is generally used in Poisson distribution, but here the mean and standard deviation of these distributions are both equal to the reciprocal of the parameter lambda, and lambda is the parameter used in this one also. So for any exponential distribution, the probability to the left of a given value x greater than 0 can be calculated with Excel exponent function. So we can calculate that exponential distribution function in Excel using this function name. So here to difference, very big difference between exponential and Poisson distribution is that Poissons try to find out the distribution of rate or arrival timing pattern, but in case of exponential distribution, here it tries to understand the inter-arrival patterns or inter-arrival times. And again here also use the lambda, but the mean and standard deviation is the reciprocal of the lambda. But in case of Poisson distribution, the value lambda is directly considered as the mean or the variance of the distribution, and this also follows the density function of the continuous random variable x as this form. So tries to understand the difference. Here you can see the curve. The exponential density function has the shape shown below, where graph of exponential density function here in this direction that is f of x, that is density function, and in this direction that is x, and lambda is equal to 1. Lambda is equal to 1, and that is why it is decaying in that exponential fashion. Because this density function decreases continuously from left to right, it most likely value is x equal to 0. Okay, so that is the structure or the understanding, or we can say significance of exponential distribution. So you can use the predefined function of exponential distribution in Excel and try to work it on different data. So in this way we can work out different distribution examples on a given data, like normal distribution, like binomial distribution, Poisson distribution, and exponential distribution. But all this distribution has a different motive and different characteristics. That is why try to understand differences, try to understand the applications, because for different applications the concepts and the type of distribution we are going to use might be different. So that is all about, this is a simple topic we have touched about. Briefly we have touched about exponential, what is exponential distribution, what is Poisson distribution, and the applications, and the basic features and the parameter used in those distributions, and how it looks like in data or in the graph. So try to explore it more, and if you have any doubt, please let me know. Okay, thank you.